Good morning. Welcome to my presentation about the evolution of a platform as a service or a PaaS from the inside. So I am from Google. I'm the AppEngine Java TL. So I joined 8 years ago, which is a long time, always working on AppEngine. So what we're going to go through today is the evolution of this platform as a service from the origin to where we are today and maybe where we want to be tomorrow. So what is serverless? You can go to some marketing slides talking about operational model. So you want your application to be managed for you. You don't want to manage the infrastructure. You want absolute security of your environment, and you want to pay only when you use. So if your app is not used, zero request, you should have zero infra, and you should not pay at all. Then it's also a programming model, service-based, so microservices interacting with each other or other services from another application. Event-driven between those services, so queues, tasks. And the last bullet is open. So we're going to go through this because initially AppEngine was seen as not open, but we're going to see how we solve this last bullet item. So if you want more technical definition, you go to Wikipedia. Serverless, what is serverless? So this is the Wikipedia entry. If you see at the second part of the definition, first paragraph, they are talking about AppEngine. So basically, AppEngine in 2008 was one of the first serverless or platform as a service offering at that time. If you look at the Google Trends between two terms, the first one, AppEngine. So in 2008, big launch of AppEngine. So you can see the trend, which is pretty big, and decreasing up to the increase of the other definition that now everybody is using serverless. Okay, but for me it's the same. Okay, I mean when I say AppEngine or serverless, I mean AppEngine is one possible implementation of a serverless platform. So the fact that the search for AppEngine diminished after 2018 doesn't really matter because the good news is serverless now is a well-known concept and used either in Google or obviously outside of Google, which is very good. So how did we get there? Okay, so I am a Google engineer. So internally we have a massively big system that we call Borg. For whatever reason, so everything at Google is running on Borg. Okay, whether it's Google Docs, Gmail, Search, YouTube, and AppEngine, or the Google Cloud Platform, which is the visible part of the iceberg of this Borg system. So I'm just dumping plenty of names here. AppEngine, GCP VMs, gVisor, Docker, AppEngine second gen, CloudRun, Cloud Function, Entos at the top. So you can barely see that you have two trees, two branches in the tree. One which is the AppEngine branch on the right side here. And the second one is the VM side, which is the Google Cloud Platform based on VMs. There is some timeline, so yeah, bottom is the origin, and the more you go up, the more you have new products. So we're going to deep dive more on the first branch, which is the AppEngine branch, but we need to keep in mind that those two branches will or are currently trying to merge in the Entos offering, which is the brand new offering from Google. So let's go back to the origin. In November 2008, which is a long time ago, a guy named Guido, I don't know if you know Guido, Who knows Guido? The guy who created the Python language. So he was a Google engineer, and he decided to do a platform as a service. So he was one of the core developer in the AppEngine back in 2005, because it took a few years to make it public. And they made it public in November 2008, saying, AppEngine doesn't offer you a virtual machine, so no VMs, but just a container where you provide your application and we're going to run it for you. You can see the video and the slides at that time. So yeah, at that time we didn't have marketing, so this was the logo that one of the engineers did for AppEngine. At that time also, if you do a search on Devoxx 2008, this was I saw this blog talking about modularity in Java, okay? So, it took almost 10 years to finally deliver the Java modules with Java 11, which is a perfect timing with this presentation because we're going to talk a lot about Java 11 as well. So 11, yeah, long time ago, but the vision was already there. We want to be serverless. We want to have modules in Java. So those slides are taken from the Google I/O 2009 session. So I just did a screen dump of the first official presentation of Java in AppEngine. So it was a year after 2008 because the first implementation was the Python runtime with Guido, and then we did Java a year after. So when you see what is Google AppEngine, you see something. You see terms like cloud computing, infrastructure, containers. Okay, so already at that time we had all the buzzwords that everybody is talking about now. On the Java-specific side, one term, so servlet, why not? It was very trendy at that time. One term here is critical, sandboxing, okay? Why? Because, you need security in a platform as a service environment. Sandboxing, the reason why you need sandboxing is you don't want two apps to see each other, and you don't want an app to see your infra, okay? Because you don't want your app to see what is Borg, basically. So we had, at that time, to restrict the JVM, remove a few classes. You could not write a file. You could not start a thread. You could not use AWT because AWT is native code. Native code means a hacker can break it very easily. So at that time, we had to restrict the JVM environment. It was necessary because, again, we were accepting your application running in a machine on Borg. So on the left side, you have the AppEngine infra, an AppEngine manager, load balancer, service provider, or the APIs, gateways to talk to other services like data store, memcache, etc. At the bottom, you have the hardware. Okay, you definitely do not want your Java application to be able to shut down a machine, obviously. So you give your app, and we need to run it securely in a shared environment. And when I say shared, it's really the Google shared cluster. Single massively big cluster, Borg. And AppEngine is one app among many of them, like Gmail or Google Search. So we want to run your application very, very securely. So in order to do that, the first thing we did is we used the Java concept. So we added the Java Security Manager, where we describe what your app could do within the JVM or not. Okay, so first limitation at the JVM level using the Java concepts of Java Security Manager, permissions, etc. Obviously, it was not enough, and the Google security is very, very strict. You cannot have one level of security. Okay, one level of security is not good. You always need at least two, and more than two usually. So we had to add another layer, which I call here an AppEngine Sandbox. It was an execution environment that was restricting your JVM. So this restriction, for example, allows, we're trapping all the syscalls that we did not want you to use. Network syscalls or critical syscalls that you can do either natively with GNI. Well, we did not allow GNI for good reason, but also via some Java APIs. So this is the second layer that we could not implement in Java using permission. We had this second layer. So with those two security layers, we could run your application at scale from 0 to n being more than 1,000, 10,000, 100,000, doesn't care, the number of JVM we can boot in this shared environment, because each application is completely isolated from another one. And again, it's not a VM, okay? So we do not have the security boundary of a machine or a virtual machine. It was really a shared process among a cluster of machines. So we were happy, the business grew a lot. And with visibility, you get many hackers trying to hack into Google. It's a job. You can make money on it, definitely. So this is, December 2014, I remember, you wake up and you see this and your boss is calling you, okay, so now it's 36 hours of non-stop work trying to understand what the hacker was trying to do. Obviously, he was sending bytecode that was not compiled by the JavaC compiler, okay? It was handcrafted bytecode trying to sneak around. Okay, sneak around, so the first level of security, the Java Security Manager, trying to access the file system, etc. So, what we did is try to patch the Java Security Manager or the second layer. So it was, a game. We were able to fix that in a few hours or days, and push in prod again. But then, a year after, you have another one, etc., etc. So basically, my life as an AppEngine engineer and the team was not really to add new features, was trying to catch up with more and more sophisticated attacks to a shared environment. Another one, the last one, 2017. So we gave this guy $10,000. Okay, so you can make money on nicely attacking Google. If you are nice, we accept your contribution and we recognize the value of what you can give to us. So the last one is 2017 as well, or maybe no 2019. Sorry, the date is wrong. So you would say, but I'm using VMs and Docker, so I'm safe. No, you are not safe. Okay. The same type of attacks now are happening on the Docker ecosystem. And it's not because you are running two Docker containers on the same machine that the Docker container cannot escape and see either the real machine or what is running on the other container next door. Okay, so this is a generic problem. So we were basically stuck. Okay, we had at that time Java 7. And Java 8, so it was 2014. So we say, let's try to upgrade our Java 7 to Java 8. And here we realize that the new bytecode of the Java 8 VM with the new invoke dynamic statement, the new bytecode instructions, we could not secure it anymore. The surface of attacks was so big that we could basically not upgrade the AppEngine Java runtime anymore. we could patch the Java 7 runtime, but we could not offer you a Java 8 environment. So we, at that time, well, in 2014, we realized that, or even before. And it took us 3 years to finally find the solution. Okay, so AppEngine was able to support Java 8 in 2017. Okay, which is, I mean, huge. Okay, compared to possibly the competition. And the reason for that is we redid entirely the AppEngine Sandbox, or now a generic Sandbox, and at that time, 2017, it was a very private project, but we decided to make it open source and name it gVisor. So gVisor is really the sandbox technology that saves AppEngine product, basically. Okay, so what is gVisor? So it's a user space kernel written in Go, so no C, so there is no, memory issue that a C compiler could or C code could introduce. And this layer implements some portion of the Linux surface. Okay, so we intercept all the syscalls that the JVM or another process can do, and we either rewrite them or route them to the real syscall or deny them. Yeah, you cannot do that. So initially, it was highly confidential and not only targeted for AppEngine, but for other internal products or even public products like YouTube. YouTube, when you do a video encoding, we are using driver that we don't know where they come from, but it's better to wrap them with a gVisor layer. So gVisor, goes between the host kernel and your application. And all the syscall that your application is doing are intercepted by this layer, and this layer can be customized. So you can extend gVisor with a network, what we call gophers, or file system layers, or database drivers. That so it's a highly customizable environment. The good news about the gVisor sandbox is inside gVisor, you have 2 levels of securities. Okay? So it means that we could finally get rid of the Java Security Manager. Amazing, okay? Because we could not fix all the attacks possible in the JDK 8. So gVisor was developed with the Google security team embedded in the gVisor team. So it's a product basically created by the Google security team. So they knew all the good principles to isolate non-trusted application. So it's a virtualization-based sandbox, so it's not a VM, and it allows most of the Linux syscalls. Okay, so what we did for the JVM, we wanted to try as many tests as we could. So we are running, for example, plenty of the Java tests to prove that the JVM is behaving correctly on top of gVisor. So we are running the more than 5,000 JTREG test, regression test of the JVM every night, just to make sure that a new version of gVisor doesn't break the JVM. And it's pretty lightweight and fast. The good news for us is now we could run a pristine, perfect JVM without modifying it or changing your bytecode or doing ugly things that we used to do before. gVisor can also run on top of containers, so it's an OCI compatible layer, and you can run it with Docker. There is a way to configure Docker to run with gVisor and containerd or even Kubernetes. So it's not only connected to AppEngine, but it's a generic security sandboxing product. So finally, we were able to launch in 2017, a few years after Java 8. We were able to migrate millions of Java 7 apps transparently. So if you deployed your app in 2012 2000, I don't know, 12 or 13 with Java 7, today this application would run without any modification from you, on Java 8. So it's using the OpenJDK 8, and because the original AppEngine product was servlet-based, we are using JD, and we upgraded the JT layer to JT9. Again, before you were using JD6, but your application was automatically upgraded to a highly compatible OpenJDK environment plus JT web app environment. Again, you provide only your application. We take care of everything else. You don't care about JD. You don't care about the operating system. You don't care about the JVM you are using. The only thing you want to have is your application has to work. So the critical bullet point here is the first one. Obviously, in this Java 8 product that we launched 2 years ago now, all the traditional AppEngine APIs are supported, and they are seen as private APIs. Why? Because if you use those APIs, you cannot move your application elsewhere because they can only run in an AppEngine environment. Okay, so this is a non-open environment, but at that time, we didn't have other APIs. The good news is Java 8 also, thanks to gVisor, allows your application to call the Cloud API, so the Google Cloud API, so the new data store, the new Fire store, the new Google Spanner, BigQuery, all those new Google services, they have Java binding in terms of APIs. You can use those APIs from AppEngine, which is also, a big deal because for all customers, they can still use the original APIs, but for brand new customers, we encourage them to use the new APIs. Why? Because if your application can use the new APIs, you can move it from AppEngine to your desktop, to Amazon, to your GKE cluster, to a GCP VM. Your application is highly portable. And thanks to Borg, we can still serve millions of queries per second and serve millions of apps. Okay, it's not. We are here for the big customers, like for example Snapchat. So, yeah, the last point. Thanks again to gVisor allowing us to open the network using gRPC calls to access other Cloud API services. We are finally open in AppEngine. Okay, so this is what we call second generation Sandbox. And you would say now, more and more people are talking about jars, fat jars, or even, entry point in a Docker file, because a jar is a container. Okay, it's a collection of user artifacts. A war initially was also a nice container environment where you can describe your dependencies in webinflib, your business logic in webinf classes, and your static content outside, but still in one single hierarchy, the war file. Well, a Docker is also a big blob of layers of artifacts, and then from this big blob, you have an entry point. This is what you want to execute. Okay, I give you a collection of tar.gzip files, and I want you to execute this entry point. This is basically what gVisor can do. Okay, so initially, for AppEngine Java 8, you could only start the JVM, starting the JT, booting your web app. But gVisor allows any type of execution environment. So this is why, last week or 2 weeks ago, we launched finally AppEngine Java 11, which is the continuation of the Java 8 runtime, but breaking a few things like accepting whatever payload that you can produce in Java. Not only a web app, and we do not provide the JT web server anymore. you provide the web server with your application. So you can see it's a big improvement. Maybe sometimes people do not care about JT or whatever, but you have the choice now to pick whatever Java frameworks. It has to be a web app, so it has to listen to a port. And you give us a jar. This jar can have dependencies to other jars using the manifest mechanism for ClassPath. But if you deploy using the Google Cloud SDK a jar, we will run it at scale. Same as before in 2008 with Java 6 and Java 7. At that time it was a war, now it's a jar. Okay? And obviously the JVM we are running is OpenJDK 11. So yeah, maybe a year after OpenJDK 11 to be out, but anyway, the adoption of Java 11 in the community is not that fast, so I think this is the right timing. Okay, so we have a real demo. So quick recap. So we can run any jar listening to port 8080 or the environment variable that we provide for you port. If you use the $port environment, we add a NGX layer in front of your JVM that is easing a little bit of things like HTTP compression, etc. You can override the entry point. So the default entry point is the classic java-jar, your jar. But if you want to add JVM flags, or if you want to run something else than Java, technically you can. Okay, so for example, if you're able to compile using the GraalVM compiler to a native application like Quercus or Micronaut, and soon Spring, and I don't know if you have seen the SpringBoot presentation about GraalVM yesterday, but they are working very hard to make a SpringBoot app native now. You can customize the entry point and say, okay, please, gVisor, execute this executable. I know it's listening to port 8080. And for us, it's more or less the same. So frameworks, anything that you can find, your framework, Spark Java, Vertex, Quercus, Micronaut, SpringBoot, JT, if you want. We have samples where we push a JT web server with your application and your WAR, okay, but you can bundle the two together. JVM languages, Kotlin, Groovy, Scala, anything that the JVM can handle. And the API, same as before. Not really. Why? Because Java 11 doesn't support anymore the original AppEngine APIs. Okay, so here, if you are an existing Java 8 customer and you did not upgrade yet to the new cloud APIs, you will have a migration effort to move from the AppEngine data store to the cloud data store, from the AppEngine task queue to the cloud task, etc., etc. So there is some migration if you're an existing customer, but anyway, we want to be only open. We don't want you to use API that would make problem for you to migrate to another platform or to a newer platform from Google. So let's see back in this timeline from 2009 to, I put 2021 and then ... I don't know when we will stop those products, but definitely not in 2021. And it will take a while, okay? But we started with Java 6 in 2009. We added Java 7 with the original Sandbox. The little Java logo 8 is when the OpenJDK 8 was launched. And the yellow line is where we were able to finally offer you Java 8. And the white line between the Java 8 logo and the yellow line is us working very hard to develop gVisor and while keeping up with hackers on the Java 7 runtime. Okay, so this is why you have this huge gap between when the JDK 8 launched and when we were able to finally offer it in this platform. So 2019, so this is now. I mean, Java 11 jar was alpha in January, beta in June, and now it's GA. Okay, so it took us a year. We could have made it a little bit faster, but the last bug we had for Java 11 was not really a bug, but a configuration on how to configure the memory management of gVisor, because we could run most of the frameworks with a default machine, but SpringBoot was causing problem with our memory management. So 256 megabytes for the base image was too small, not because of SpringBoot, but the way we accounted cache files in the cache layer. So we were able finally to solve this bug. That's why now we have a GA product. So I didn't mention all the other runtimes that this platform is offering, but obviously all the AppEngine runtimes like Go, Node.js, Python, PHP, Ruby soon are based on the same stack. And I'm adding two new products called Cloud Function. I don't know if you have heard about Cloud Function or CloudRun. So those products are based on AppEngine, sharing the same infra and the same stack, but offer different user experience and sometimes more capabilities or sometimes less. Okay, so we're going to deep dive a little bit more in CloudRun, but I wanted just to, to see things in perspective. So we have been talking about Borg, AppEngine, gVisor, AppEngine second gen. Again, I did not look at the GCP VM because this is VM, too complicated for me. Not for you, but for me. And now we're going to talk about what is CloudRun and Cloud Function, which is equivalent but for one single function, based on the same stack. So CloudRun is a new beta product where instead of giving us a jar file, and we manage the execution environment of this jar file for you, you give us a container. So anything that you can put in a Docker image, JS, Ruby, Go, Python, Rust, whatever, any library, any binary, as long as your entry point is executable and is listening also to port 8080, we will run it for you. Okay? So you have your container, your image, you can push it to prod and use the same autoscaler of AppEngine. Okay, we're not talking about scaling to 5, but we're talking scaling to possibly millions of Docker instances. Not Docker, gVisor processes running in the Borg environment, and back to zero. The nice thing about CloudRun, which is a product, this product can be installed in multiple targets. The one which is fully managed, fully hosted, which is on top of gVisor, but you can run also CloudRun on CentOS, on competing platform as a service environment, or even on-premise. Okay, so the same programming model and deployment environment will or is running on top of CentOS as well. So quick recap of why you want to use AppEngine or CloudRun. So ingress, HTTPS, yes. Custom domain, of course. URL mapping, yes for AppEngine, no. What it means is the same AppEngine top-level domain can have multiple services. It's not as easy with CloudRun yet. Traffic splitting is available, obviously, since 2009 in AppEngine. We are working hard to make it happen in CloudRun, but it's not there yet. Traffic splitting is amazing. You deploy n version of your application, and you can switch back and forth between two versions. AppEngine already has a min-max instance, so you can finely tune the autoscaler if you want. And the autoscaling is a little bit more fine-tunable in AppEngine as well. So why would you pick AppEngine or CloudRun? Okay, so it's your decision. If you do not care about, if the only thing you care about is your application, your business logic, and you do not want to manage a Docker environment, you do not want to manage a base image, you do not want to manage automatically the upgrade of the OpenJDK 11, but you want to use OpenJDK 13. If you do not want to handle this and only manage your application, you are better with AppEngine. Why? Because you give us a jar or a collection of jars, and we will update everything that the jar needs. So we will update the OpenJDK 11 version. So from 11.04 to 11.05, it will be a transparent upgrade. Next time you wake up in the morning, you will have a new JVM running your application. The base image we are using is Ubuntu 18.04. Again, here we manage it for you. So all the possible Ubuntu updates will be done automatically for you. OpenSSL, all the dependency that you may need from our base image are fully managed by AppEngine. On the other side, if you give us a container, a Docker image, you are in charge of what is in this image, okay? So obviously, if you run a security scanner on those images, you will see that many times a security scanner is seeing that you have to patch. So you have to find a newer version, you have to recompile your image, push it to the registry, and then deploy it to CloudRun. So you are in charge, okay? With freedom comes responsibility, because if you deploy your container now and do not touch it for a year, I mean, in a year from now, it might be a little bit less secure than today. So AppEngine, you give us deployables, which is a jar or a directory containing a configuration file called app.yaml, where you can add extra configuration, but the app YAML is optional. And CloudRun, you give us an image. Okay, so gcloud beta run deploy -- image, and then an image to a GCR repository. Okay, so before we jump to samples, this is what you would have to add on top of a Java app to make it CloudRun ready. So either you have your app, but you might want to build it using a builder image from Maven, for example. So you copy the source and POM, you manage package, skip test, I don't know why, but this is what I've seen on the web. So then you pick a distro, OpenJDK. So here it's hard-coded to be 202 B08 Alpine. So Alpine, you don't know who is maintaining it, but it's your choice. And then finally, you copy the two interesting things for you, which is your app called hi.jar and potentially dependent jar that usually are either embedded in your fat jar or in a relative directory called lib. And then you give an entry point or a command. Okay, so let's now, enough talks. We have 11 minutes, so it's about time to really do some demos. So I wanted to, I don't know if you have seen yesterday, Emmanuel Bernard talking about Quercus launching as 1.0 version. So I'm using Visual Code, even though I'm not a guru in Visual Code, and I installed the Quercus plugin for Visual Code. So I can generate a Maven project from scratch using the Quercus. Is it big enough for you? Yeah? Good? Okay. So I pick all the defaults. So this is the group ID, the artifact ID, the project version, etc., etc. And I pick 0 extension, okay? But I could pick all the possible Quercus extensions that are available. So I generate in this directory. I override because I already did it. Okay, and here I have a new Quercus project. So we can look at this guy. Let's change it to make sure that we are using this resource here. Okay, so standard Java 11, and JAX-RS resource. Go to the POM. It's 1.00. Yeah, it's not, well, they did not update their version yet for this plugin, but let's do it. Let's compile this application. Okay. Done. So I'm going to the target directory. So again, here there is nothing specific to AppEngine. You have this runner jar here, which is an executable that depends also on the lib directory here, where you have all the dependency. So I will just use, let's move this a little bit up for you. So the Cloud SDK command, gcloud app deploy, and the jar. Okay, so no configuration. What it means is we are generating a configuration for you, which says runtime Java 11, and then all the default AppEngine flags. So you are running on a 256 meg environment called F1 for front end, and you are using all the default scaling capabilities of AppEngine. You have no URL mapping, no security mapping on URLs that you can do with AppEngine, but you are only using the default environment for AppEngine. So here, the deployment is happening. So I will copy-paste this URL because this is where the application will be serving, I think. Let's go back to here. So it's serving. So this is the index page for the Quercus default project. And here I started the hello. Oh, okay. So I'm not picking the right one. I'm not picking the right one. Something is wrong here. Anyway, let's go and see in the console what happened. Maybe I did something wrong. AppEngine version. Okay, so I deploy this project when? Yeah, right now. I can see the logs here. Hello, yeah, it has been called. I can see the default configuration that was generated for you. So runtime 11, environment standard, instance class F1, and everything default. Again, all those flags can be customized in a local app.yaml file before you deploy. The nice thing about it is you did not write an entry point, you did not write a Docker image, you just deploy your jar. What you can do easily also is debug. Okay, so this is a very nice AppEngine feature or a Google Cloud feature. For now, we don't have source code, you have only the jar, but you can add source, you can upload it from either a GitHub repo, or here I have from my local repository. So here, I don't know where, I don't know where it was, sorry. Not this one. Too many tools. Oh, A, okay. Okay. So go back to the console. So I will upload from A. This guy. And I'm just uploading the src directory. Okay, so it's just to make the Cloud Debugger aware of the source code that you have. Okay, so now I have this code here. And this is where you can set a breakpoint. Okay, so I changed the wrong one. So it's really hello that we deployed, sorry. Okay, so here I'm setting a watch point, or which is called a snapshot. So basically, next time I call this endpoint here, and it can be from any VM. Let's say you have 10,000 JVMs, and you have a bug in one of them, you don't know which one, and it throws an exception, I don't know, at midnight, something is really strange, you don't know why. And instead of changing your code, doing a println of the environment and recompiling, redeploying, in prod, you don't want to do, you have rules to redeploy. You can just add a snapshot, and the first JVM that will hit this line will not stop. Okay, will just capture the environment and give it to you. So here we can see the environment, the variable this. So it's not very interesting on this case because it has no field. But if you have all local variables, you can introspect them and variables from the parents, etc. So it's like a debugger, doesn't stop, but at least you can watch your application, and you can have condition, obviously, like a debugger. So again, you just deploy a jar. Obviously, we did not have the source code, so you uploaded the source code, and we are able to introspect the application without doing anything. Going back to the AppEngine dashboard. So before the talk, I did some load testing. I used the load testing tool on my machine, trying to send as many requests I could on this instance. So here, we were able to run 1,000 requests per second. So it's count per second. And if you look at the number of instances that were booted, up to 63 at one point of time. Okay, so again, depending on how many customers you have, most of the time you have 0 in my sample. But and again, it was only from my Mac using a load testing. But you could have all done your own load testing, and the only thing that we would have done is increase the number of JVMs automatically for you. There is no upper limit. Except your credit card, basically. So you just need to have a correct billing environment so that we can scale it to whatever. And then after my load testing was done, back to 0 quite quickly. So now we have 1 more minute. Let's try to do the same environment with CloudRun. So here I'm cheating a little bit because I didn't want to compile Quercus in native mode. It takes a few minutes. I didn't want to do a Docker build. I didn't want to do a Docker push. I already did that before. So I have a Docker image in my GCR repository. Okay? So I am in the CloudRun view of the console. And we want to create a service. And here, the first entry, again, everything can be done in command line, but I'm doing from the UI. We are looking at your GCR repository. I have two versions of Docker image, so I pick the latest one. US Central, the service iDevox. I want to authorize invocation from non-authenticated people, and I use the default. So here, instead of starting from a jar, we are reading the GCR Docker image and deploying to a CloudRun environment. So it takes, I don't know, a few seconds. Yeah, done. Okay. So instead of using appspot.com, we are using a new domain name called run.app, but you can use your own domain. And what is it? Hello. And it should say, yeah, well, whatever. Okay, but reply. Okay. So same thing, but I had to do my own Docker image. I had to pick the OpenJDK. I had to pick the base image, which is Alpine. If you go to the GCR repository here, and I have 0 minutes to finish. Where is GCR? You will see that my image is here. And in fact, if you see the vulnerability tab, entry, you have one thing which is not clear. Okay, it's not a red flag, but in half a day, I did it yesterday, I have already one warning for security. Anyway, if you have questions, we can do it outside because I think the time is running out. So thank you very much for attending, and enjoy either AppEngine or CloudRun, depending on what you want to do.